All right, so this is pre-calculus 38.4, and we are at number 13 here in our notes, or in our textbook. And it says the compound interest formula is given here, a equals p times 1 plus I to the power of n, where a is the future value, p is the principal, I is the interest rate per compounding period, expressed as a decimal, and n is the number of compounding periods. Okay. All right, so yeah, actually, if we look at this here, so let's whoops, I don't want black here. A equals p times 1 plus I, and this is to the power of n. So what we're looking for here, David inherits $10,000 and invests it. So that's going to be our principal, right? $10,000. 6%. Okay, so now remember, I is actually, I'm not sure if you did this or not, but I is the interest rate per compounding period. So if it's 6% annually, that's usually the annual rate. So compounded semi-annually would be I is 3% because it's every half a year. So this I right here is 0.06 divided by 2 because it's semi-annually. I'm not sure if that was done earlier. How long will it take for the GIC to be worth 11 grand? Okay, 11,000. So that's here, 11,000. And how long? That's asking about compounding periods. So, so let's fill some things in. Well, 11,000 is our end goal here. That's what we're going to end up with, and we're looking for the time. So it's 10,000 is put in. And we've got 1 plus, and this I is the annual percent per compounding period. So this is going to be 0.03, and then this is to the power of n. Okay. Okay, so what we're going to do is we're going to use logs to get this out of the exponent position for sure, but you don't want to have this hanging around, okay? This, remember, is just multiplied. This is just 10,000 times all this. Let's get rid of that 10,000 first, okay? So let's divide both sides by 10,000. That's going to be 1.1 over here equals 1, and you can add these up because they are inside the brackets, safe and secure from anything else, so we can combine like terms in there. That's 1.03 to the power of n. Okay, so don't worry about all this, you know, GICs and, you know, don't APR. Okay, don't worry about all that. It's just it's a math formula. You've got all these things, and you're trying to solve for this one, and just focus on the math formula. That's the big thing, is extracting that information out and doing the math on it. So now that we've got this far, this is really easy, right? You can now take the log of both sides here, log of this and log of that, and we can rewrite this as log of 1.1 here. This is now n times log of 1.03, and this is now just multiplied. It's not to the power of anymore like it was up here, it's just multiplied. So now I can divide by log of 1.03, log 1.03, and now I have n equals this right here. So let's do that on our calculator. So let's turn that on. So log of 1.1 divided by divided by log of 1.03, and that should give us 3.22. Okay, so what does that mean? 3.22. Well, there's 2 compounding periods per year, right? So if you think about, this is 1 year, there's 1 compounding period, there's 2, and then the second year, this is the third one, and then 0.2 is like around here somewhere. So it actually hits 11,000 in this time frame right here, but it's not going to get calculated until the end. So you'd have to say this is year 1 and this is year 2. So then you'd have to say, because there's just a little less than 4 compounding periods, you'd have to say after 2 years this would go. Okay, so that's number 13. That's the math behind it, and hopefully that helps.